Hello, good morning, class. Today we are talking on matrices. And what are the things we want to look into when I'm talking about matrices here? Firstly, we want to understand what is matrix, then the order of matrices or of the matrix. Then we now go to some other things such as addition and subtraction of matrices. Now, a matrix is described as the order of arrangement of number, as the order. Or let me say a matrix is the orderly arrangement of number, but particularly or in most cases in a rectangular form. While matrices is the plural form of matrix. Now, order of a matrix. A matrix is named in the order of rows by column. That is to say, we consider the vertical one as the row and the horizontal as the column. That's why I described here that row, this is the arrangement along the vertical. Column, this is the arrangement along the horizontal. So 3, 6, 1 are on the same row. 1, 7, 5 are on the same row. While 3, 1 are on the same column as 6 and 7 are on the same column. Just also as 2 and 5 are on the same column. I believe it is very clear to us that way. Yeah. Now, in this case now, we are going to look into what we have here to name the order of the matrix. Now, look at that first one. We have a matrix of the first row, 1, 3, second row, 12 minus 1, third row, 1 and 2 for the first question there. Now, let's first of all bring that out here. So that means that we have 1, 12, 1, then 3 minus 1, then 2. Now, we say we name by what? Row by column. Row by column. Now, let's now take the first row. How many rows do we have there? Sorry, rows by columns. We name in the order of rows by column. How many rows do I have? 1 is the first row, is the second row, is the third row. So I have 1, the second, the third, as 3 by how many columns do I have there? I have first column, second column. So I have 3 of the rows and 2 of the columns. So in that way, I'll be having 2. I will write this as 3 by 2. So for the order of arrangement here, the first one is 3 by 2 matrices or matrix. 3 by 2 matrix. So for the second one now, let's move to that. There we have 2, 1, 8. I have 2, 1, 8. I have 5, 3, 6. And I also have 4, 7, and 3 in this matrix. Now let's now check. I have how many of the rows? 1, 2, 3. How many of the column? 1, 2, 3. So checking by that now, rows. We have 1, 2, 3 of rows by column. 1, 2, 3 of column. That's 3 by 3 matrix. 3 by 3 matrix. Now go to the third one. In the third one, I have 1, 7, 3. Oh, I have just a single row here and 1, 2, 3, 3 columns. So I'll be having here 1 by 3 matrix. This 1 by 3 matrix, when we have a single row, we call it row matrix. A row matrix. Because I have only a single row given in that place. Now let's consider the next one here, where I have 5, 7, and 6. So I have the first row, the second row, the third row. So under row, I have 3 for the fourth one. Then by under column, there's only one column given. There's only one column given. So I'm having only one column given. That's 3 by 1 matrix. 3 by 1 matrix. In this case, we call it a column matrix. A column matrix when only a column is given in or for the matrix. It's called a column matrix. Now, from what we have here, it is easier for us to know the number of elements in a given matrix, meaning the number of values that are being arranged in this given matrix or matrices on the table here. Now, for the first one, let's go and check. We have 1, 12, 1, 3, minus 1, 2. How many of them? 1, 2, 3, 4, 5, 6. We have 6. It is easy to determine by checking the row and column. Meaning from here now, I can get that 3 times 2 is giving me 6. So in that matrix, I have 6 elements by counting them. 6 elements by counting them. In this case, here I'll be having 3 times 3, the row times the column, giving me 9. So therefore, I'll be having 9 elements in that matrix. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm having 9 elements in that matrix. 9 elements in that matrix. Now for the third one, let's see how many elements do I have here. 1, 2, 3. Let's check. This is 1 times 3, the row times column, which is going to give me 1 times 3 is 3. So I have 3 elements in that matrix. Is that true? Yes, we counted it. It is true. And also for the last one, that 3 times 1, which is also going to give me 3, which therefore means I have 3 elements in that last matrix. So to decide or to get to know the number of elements in a matrix is easier when you already know the order of the given matrix. Now from this place, we don't want to waste time. Let's quickly move on to some other thing. When we are given a matrix, or what are the possible things we do under matrices? Well, it is mathematics, so definitely you will be expecting some calculations. Now let's first of all move to the issue of addition and subtraction under matrices. Addition and subtraction under matrices. Okay, let's have an example to work with. Now let's take maybe we can take that one for example. If matrix A is, sorry, 2, 1, 8, and 5, 3, 6, and so let's take it as B being 4, 2, 3, 6, 1. Let's take it as a 2, and matrix C being let's take a look into what I have, some of the values I have in my textbook here. Here I have 3, 2, 1, 3, 2, 1, 0, 1, 0. All right. From this now, let's see what we can do. If we are told to what? To find the addition, okay? Let's now find 1A plus B. 2. Let's find A plus C. 3. Let's check B plus C. 4. Okay. Instead of B plus C, let's take B minus C to save our time. With this and this, we should be able to understand how we do the addition of matrices. And also, let's take another subtraction. Let's take A minus C likewise. Okay, now going to the solution. How do we address this kind of a thing? Each of these elements we map onto the other one. So what do I mean? Let's have the matrix A being 2, 1, 8, 5, 3, 6. Now being added to the matrix B. Let that be A plus B. Matrix B is 4, 3, 1, 2, 6, 2. Like I said, each element will map onto the other. So therefore, that means I'll be having this first element here, 2, to map on 4. Then the next element, 1, we map onto 3, meaning this second value there, which is 1, being on the second row, but still on the first column. Then the third row, 8 plus this one here of the third row of B. Then also we come back to 5 plus this 2, then this 3 plus this 6, then this 6 here plus this 2. So we have at the end addition of each 2 plus 4 giving me 6, 1 plus 3 giving me 4, 8 plus 1 giving me 9, 5 plus 2 giving me 7, 3 plus 6 giving me 9, then 6 plus 2 giving me 8. So this will be the value of our A plus B from the question, Roman figure 1. Let's quickly move to the remaining part of the question, where we're having A plus C. With what I have done now, I know possibly you'll be able to be doing, to solve that even before getting there together. So we have A plus C. My A, according to what I have here, 2, 1, 8, 5, 3, 6. Plus my C, 3, 2, 1, and 0, 1, 0. So from what we have here, what do we do? Just like I've explained, each element will map onto a corresponding element from the other matrix. So therefore, I'll be having 2 plus 3. And I'll be having 1 plus 2. Also 8 plus 1. Then this 5 plus 0. This 3 plus 1. This 6 plus this 0. When you are arranging your home, when you are solving yours in your own notebook, please endeavor to make sure that there's space to show your workings or what you are doing, or preferably, you can just include brackets to help you identify what you are doing properly. So from there, I can have 2 plus 3, 5, 1 plus 2, giving me 3, 8 plus 1, giving me 9, 5 plus 0, 5, 3 plus 1, 6, 3 plus 1, 4, 6 plus 0, 6. So I have this as my answer for that question. Now let's now see B minus C. So there I have B. My B is given to be 4, 3, 1, 2, 6, 2 minus 3, 2, 1, 1, 0, 1. 3, 2, 1, 0, 1, 0. Now from this, our next step, just like we did to addition, exactly the same thing we're going to do to the case of subtraction. The first element we map onto the corresponding element of the second matrix. That's 4 minus 3, then 3 and 2, 3 minus 2, then my 1 and 1, 1 minus 1, then 2 and 0 here, 2 minus 0, Then 6 and 1 here, 6 minus 1. Then my 2 and 0, 2 minus 0. So I will now have my 4 minus 3 will give me 1. My 3 minus 2 will give me 1. My 1 minus 1 will give me 0. 2 minus 0, 2. 6 minus 1, 5. And 2 minus 0, 2. So this will be the value for my question there. Then to the last one, okay, permit me to use this. Okay, let me just rub that off. Now we have A minus C, where my A is 2, 1, 8, and 5, 3, 6. To subtract 3, 2, 1, 0, 1, 0. So there I'll be having 2 to map onto this 3, minus 3. My 1 to map onto this 2, 1 minus 2. Then my 8 to map onto this 1, 8 minus 1. Then my 5 now will map onto this 0, 5 minus 0. My 3 will map onto this one, 3 minus 1. Then my 6 will map onto this 0, 6 minus 0. So from there, I will have 2 minus 3 minus 1. 1 minus 2 minus 1. 8 minus 1, that will give me 7. 5 minus 0, 5. 3 minus 1, 2. 6 minus 0, 6. That would be the answer for that. With that, I think we've been able to give a good justice to addition and subtraction under matrices. Now, with this knowledge, let's quickly move to scalar multiplication of matrices, because under scalar multiplication of matrices, we're still going to have the involvement of addition using scalar multiplication of matrices. Now, quickly, okay, in this case now, let's take our example. For instance, where we had a given that A is 218536. B given as 431262, and C being given as 321010. So from here now, if I'm to have a scalar multiplication, find 2A, 3B, 2C. Then also we can now go further to find 2A minus C. Then to the last one, I can go further to say I want to find 2C minus A or minus B. Now, let's now move to this. The scalar multiplication simply involves the multiplication of the value having its distributive effect on every element in the matrix, having its distributive effect on every element in the matrix, meaning it's going to multiply every element in that matrix. For instance, now where I'm having 2A, that means I'll be having 2 into the matrix 2, 1, 8, 5, 3, 6. So in this case, I'll be having 2 to multiply these two. These two will multiply these two. 2 to multiply this one. These two will multiply this one. Then 2 to multiply this 8. These two will multiply this 8. Then these two will also multiply the 5. These two will also multiply the 3. And these two will also multiply the 6. So in that sense, I will eventually have 2 times 2, 4, 2 times 1, 2, 2 times 8, 16, 2 times 5, 10, 2 times 3, 6, 2 times 6, we have 12. So in that sense, I'll be having my 2a as 4, 2, 16, 10, 6, 12 in that matrix. Then for 3b, just doing the same thing or a similar procedure where I have 4, 3, 1, then 2, 6, 2, which will give me my 3 to multiply this 4. Then my 3 to multiply this 3. Also my 3 to multiply this 1. And my 3 to multiply this 2. My 3 to multiply this 6. And my 3 to multiply this 2 again. So with that, I'll be having 3 times 4, 12, 3 times 3, 9, 3 times 1, 3, 3 times 2, 6, 3 times 6, 18, 3 times 2, 6 again. So this will be my answer for 3B. Then for my 2C, just the same way now, my 2C, even we will not even need to go through this long procedure anymore. So you already know what to do in that case. So let me just have it as my C is 3, 2, 1, 0, 1, 0. So 2 times 3 will give me 6. 2 times 2 will give me 4. 2 times 1 will give me 2. 2 times 0 remains 0. 2 times 1 giving me 2. 2 times 0 remains 0. So this will be the answer for that. Now moving to the last two questions under that example. So this is in these two questions here, it's just an equation involving scalar multiplication, or let me say scalar multiplication in equation. So we have 2a minus c, which give me 2 into, what's my a? 4, 3, 1, 2, 6, 2, minus my c being 3, 2, 1, 0, 1, 0. So from that, I will have to multiply this first 8, 6, 2, 4, 12, 2 times 2 giving me 4. So with that now, I can go on to subtract my C from my A. So from there, like I said during our addition and subtraction, each element will map onto the corresponding one. 6 to 2 as 2 to 1. Then 4 to 0. Then 12 to 1. Then my 4 to this 0 again. Then from there, I can move on. My 8 minus 3 is 5. 6 minus 2, 4. 2 minus 1, 1. 4 minus 0, 4. 12 minus 1, 11. 4 minus 0, 4. So this will be the answer for 2a minus 6. This will be the answer for 2a minus 6. Now to the last part of that question, where we have 2c minus b. I have 2c minus b. That will be 2 into my c, being 3, 2, 1, 0, 1, 0. Minus my b is 4, 3, 1. Sorry. Something happened, a mistake on that first question. We were using the value for B instead of A. So which means this is wrong. So this will be wrong. All right. Then what do we have as A? 218, 536. 218, 536. So multiplying that, 2 times 2, 4, 2 times 1, 2, 2 times 8, I have 16. 2 times 5, 10, 2 times 3, 6, 2 times 6 will be 12. So from there we have 4 minus 3, 2 minus 2, 16 minus 1. And I have 10 minus 0, 6 minus 1, then my 12 minus 0. So by the time we sum that up, we have 4 minus 3 being 1, 2 minus 2 being 0, 16 minus 1 being 15, 10 minus 0 being 10, 6 minus 1 being 5, then 12 minus 0 being 12. That will be our answer. So that my 2C minus B now will be 2 into my C is 3, 2, 1, then 0, 1, 0. Minus my B being 4, 3, 1, 4, 3, 1. My 2, 6, 2. 2, 6, 2. So from this now, let's now move on. I will have to open up this by multiplying. Sorry, I will have to do the scalar multiplication of 2 to matrix C. So I'll be having 2 times 3, 6, 2 times 2, 4, 2 times 1, 2, 2 times 0, 0, 2 times 1, 2, 2 times 0, 0. Then that I will subtract my B, which is 4, 3, 1, 2, 6, 2 from that. So with that, you know what to do. I'll be having 6 minus 4. 6 mapping onto this 4. Because the function there, I mean the sign is to subtract. Then this 4 minus this 3. 4 minus 3. Then this 2 minus this 1. 2 minus 1. I have 0 minus 2. 0 minus 2. My 2 minus 6. 2 minus 6. And I have 0 minus 2. 0 minus 2. So at the end, I'll be having 6 minus 4, giving me 2. 4 minus 3, giving me 1. 2 minus 1, giving me 1. 0 minus 2 is giving me minus 2. 2 minus 4, 2 minus 6, giving me minus 4. Then 0 minus 2, giving me minus 2. So that will be the answer for that. Okay, I would like to stop here for today. So the next class, we'll be going into other aspects of matrices. Thank you.